Wonderful. So thanks everyone for joining, anyone who's here. I'm very thrilled to be here with Yagel. We will present ourselves shortly once we get all this set up. And yeah, we will start the fun. You ready, Yagel?
Yeah, ready.
Cool. So before we start, anyone that has a question, there should be some Q&A box somewhere here that you can submit it, and we will try to answer it to the best of our ability. Hopefully, we will answer it during the webinar, but if not, feel free and welcome to submit whatever is on your mind. So without further ado, let us introduce ourselves.
Yes.
Yeah, Gil, would you like to start?
Yeah, of course. I'm Yagel. I'm a security researcher at Hunters. And previously I was a detection engineering team leader at the defense ministry or like sector.
Cool, and I'm Ophir Kelman. I'm currently security research team leader at Hunters. I've been here for the past 4 years. Before that, I was also part of the defense industry for almost 7 years. Went through several research areas, none of which relevant for detection engineering. So this is just from the past 4 or 5 years. And yeah, so today let's look at what we are going to go over. This is our agenda. So the main topics are going to be creating a rule. Yagel, would you like to give us a little bit of taste of that since
Yeah,
you
of
thought
course.
of this topic?
So right, the whole topic of this webinar, of course, is to determine how how well is your detection and what you can do about it, right? And we believe that the first thing you can do is make sure that when you create the rule, then it's good. Like a good foundation can support a good building. So it comes from the start. Like the process starts at the very, very, very beginning. Yes. Another
Cool.
thing that we have that the importance of context, we're going to talk about that because it can really make or break a detection. Then we have the KPI section, right, Kelman? That is your forte.
Yes, yes, thank you. Mine and yours, if I can compliment you too. It's kind of the business we're in, right? It's the core, the uh, main thing we do. So this section is going to be hopefully longer and more juicier. And right after that, we're going to detection engineering lifecycle, which we might call DELC from now on, if
I don't know if
we
we
are going to
invented that
be.
or that's a thing, but now it
Yeah,
is a thing.
yeah. Uh, and after that, we're going to discuss some interesting topics about cost and performance.
Which is just as
And
important.
yeah, and after that, takeaways and questions. Cool.
Let's begin.
So, ready to dive in again?
Yeah, let's go.
Yeah. So, creating a rule.
Yeah,
Why
so
don't you start?
as we said, the very beginning is where you should put your whole focus because as we said, if the rule from the beginning is not that good or you didn't really put that much thought into it, then you're going to have problems in the future. What kind of problems? Let's say I have a detection which is really hard to maintain. I have a whitelist of processes that create a lot of noise or whatever, and then I have to go back periodically and update it. It's going to take a lot of manpower. It's going to take a lot of time, and the noise is just going to keep piling up because I can't keep with it. That's one thing. Um, so what we kind of recommend for you to do at the beginning, things to look at is first try to determine what kind of data you need for this. Not only for the detection itself, like not only the logs you need to support this the thesis, but the logs you need to investigate it. And we're gonna touch on that on the context section. Um, Another thing is try to actually simulate it when you create the rule and understand what you catch, what you don't catch, why you didn't catch it. And also, that's a great opportunity to use the noise in your environment and all the results that you run from like a sort of like a threat hunting test for this thesis. And then you can understand what can I do with noise, what kind of noise exists, what is the truth positives, how do I investigate them, how do I tell the analyst to investigate them. All of this you can do at the very start, and that's really valuable. And the final thing is, what kind of technology do I have in order to support that detection? Because not every platform has all the kinds of technologies, and by technologies I mean, for example, using machine learning and I don't know, statistical time series analysis and stuff like that. Some theses very benefit from that, and some just need a simple select from. Some platforms don't even have joins. So it really depends on what you use and what you have to your advantage and how you use that. So try to determine what kind of technology or detection needs and if you can answer it.
Let's talk a little bit about the first point about
Yeah.
not getting too attached.
Right.
I think it has a lot of merit to it, because sometimes you're trying to make a rule work so much and so hard, and you find yourself investing a lot of energy, a lot of time, and it's still noisy and it still has some coverage gaps, and sometimes it's just not worth it.
Right.
There almost always some alternative to catch the same scenario or a similar scenario, or the attacker in a later stage, which can be perhaps much more cost effective and higher quality. Well, what do you think?
Right. One example I have of this is a detection that relies too much on exclusions. If I have a detection and half of the logic is just not X or not Y or like a big string of knots, then that is not really good because again, those knots are going to pile up and there's going to be a lot of noise, and then you have to come back periodically and touch it again. So in that case, if you see that you need to have a lot of exclusions for the detection to be relevant, I'd say drop it. Maybe in the future you'll have a better tool to tackle this problem. Um, but for now, it's not the best.
Yeah, yeah. I wanted to discuss a little bit about the rule's purpose. So obviously, there's the first rule in an empty, clean slate environment, but this is like under 1% of the times that we come to an environment. Usually, we already have a lot of rules in place, and when we come to create a new rule, we have some sort of purpose or objective with that. It may be an attack surface that we are trying to expand the coverage for. It may be a new emerging threat that we got informed and we want to detect. That will impact the development of the rule greatly, in my opinion, and we should always keep that in mind, because the naive way would be like go into MITRE metrics and check all the boxes. And obviously, while it may have its advantages, it's unrealistic and impractical. So whenever we create a new rule, the context of why we are creating it is important and impacts a lot of the development of the rule.
Right. Another thing you can look at is that can actually determine the purpose is how do I investigate this? And why is it good? Well, some rules that have a certain investigation kind of flow can be a little bit not as relevant. So let's say, for example, there is a certain rule that I can only validate if I call the user or the end user, or like this is the main investigation step. Not always I can rely on him, right? He doesn't even know what he's done. Sometimes he can maliciously say yes, it's all okay, and then the analyst is going to dismiss it because who can you trust if not the person that just did that, right? So let's say that's a big part of the investigation, then this rule might not be as relevant.
Yeah.
Best kind of things is stuff that you can determine from the logs only, and as we're going to talk about in the context section, you don't need to dive out into other areas.
Yeah. One last thing I want to say before we move on to the next slide is the use the right tool for the job. It's very easy as a detection engineer to like take your best, most sophisticated UEBA or model and add it to your detection logic. I suggest to be very careful with it. There are cases where it is very beneficial, but sometimes the cyber logic of the behavior that we are trying to detect is accurate enough. If we are trying to detect a login under certain circumstances with a specific token, with auth, for example, or with a legacy protocol, so we might not need those heavy guns of UEBA or time series analysis or trained models. So sometimes the simple way is the best way. Moving on. Context.
Yes. So we already spoke, we did a few spoilers before that about the importance of context, but really context can make or break an alert in many ways. And not only that you need to have the context available, you need to have it easily accessible. Because if I need to go out to other systems or like other tools in order to investigate the alert, then this A might take a lot of time from your analyst, right? You have so many analysts and so many rules in your SOC queue to investigate, and adding time to the investigation can be really detrimental, and you can miss out a lot of important things. That's also hurts the priority, right? Because if certain alert takes a lot of time to investigate, then I might put it aside from now and investigate other things, and that can lead me to missing important alerts. So it should be available and it also should be easily accessible. Um, and why is it also impacting the alerts themselves? Because if the alert is hard to investigate, then sometimes it is kind of useless. So let's say, for example, I have an alert that a process has opened the handle for another process, right? That means nothing to me at first. I need to determine, does it usually happen? What is the process? What is the target process? Um, did I see any of this before? Right? Those are all the things that can tell a story to me, and then I can differentiate between a false positive, a true positive, or anything in between. Right? So without context, the alert is just a string of text.
Yeah, and the more that we manage to provide that context as close as we can or as accessible as we can to the alert itself, I think it improves the user's experience a lot. It reduces the triage time by a lot, and generally results with better verdicts, like better triaging and better life for the SOC.
Yeah, I saw
Uh,
in many examples that sometimes when investigating an alert becomes hard for the analyst, or it needs to go out and do a lot of steps to get to the data itself, then kind of the investigation becomes some sort of a routine for it, right? And he has the steps in his mind and he done that 1,000 times. And when the alert is actually malicious, like we detected something important here, then he's just gonna wave it off because he did that a lot of times
yeah,
before. It kind of becomes muscle memory, and that could be very bad.
yeah, and by providing the right context, we can like taking him out of that routine,
Right.
like having like a light bulb, uh, metaphorically, of course, near the alert.
Or not.
I think, or not, but it can really help differentiating within the alerts and prioritizing if you have a scoring system. So yeah, and obviously better context results with more actionable alerts. We're going to talk about actionability a little further down the presentation, but I think it's pretty obvious and pretty important that the more context that the alert has, the more the analyst or the user uh, can process it better, can work with it better. He may know what to do shortly, or it can cut the triage time for him and maybe reduce the time of little research that he needs to do, analysis he needs to do, if he needs to go back to certain logs to see activity. So better context can just point him in the right direction immediately, and he knows, okay, for example, let's say he has an alert for curve roasting, and the additional context we provided for him is that usually this user does not request this TGS with such a low encryption type. So this context is very interesting for him because among all the curve roasting alerts, he says, oh, okay, so this is double unusual.
Yeah, that's a great point.
Cool. And that moves me to the last point of context, which is there are kind of two kinds of context, or at least this is how I think about them. There's context which is rule specific, like the example I gave with the Kerber roasting, information which is only relevant to the detection rule at hand. And it may be like a great win if we can find that information within the same event or another data source, if we can add it later. And we have more generic enrichments, for example, IP reputation. So if we have an alert about some sort of anomalous login, we would really like to know a lot about this IP, what its geolocation, ASN, etc. Maybe even some threat feeds, uh, so on and so forth. I think we're ready for the next slide.
Yeah, but before we continue, I just want to say I don't see any questions yet, and this topic is we can't really talk about everything, so I'm sure there are things that are unanswered. So feel free to send your questions.
Good point. Good point. At least I have you with me, Yagel. Cool. So we got two KPIs.
All right, this is the big bulk of this is mainly how do I measure the quality, and we spoke about the beginning and what can I do to make sure that the detection is going to be solid right from the start. And now, how do I measure it, right? So we have few measures. Um, One of them is the classic signal to noise, right? Ophir, you want to talk about that?
Sure. So this is like the bread and butter of our work. Most of our time, or a lot of our time, is dedicated to reducing noise, reducing false positives, and reducing false negatives, like expanding the coverage which we have. So SNR covers it pretty much. And I put three bullets here. The first one talks about acute versus chronic noise. So there are rules that the moment that you deploy them, you see that they are noisy across all environments without exception, and it's easy to detect or monitor their noise. It doesn't have to be in the immediate deployment. It can be like several months after because there was some changes either in the environment or the technology. But the point is that it's chronic. It's everywhere. It's always every day that you're gonna look, it stays that way. And there is another type which is more nuanced, which is acute. In some environment, someone deployed new service account which did some new behavior, and now your rule became noisier. KPI for that might be a little bit more tricky, but I think it's important because this happens a lot for SOCs, and it's painful, and the investigation of it is pretty painful. And if you take it as a monitoring subject, you can detect it beforehand and prevent from it happening down the line again. Next point is silent rules. This is a hard one because when you have a silent rule means that this rule has never fired, never created an alert. And it may be because the rule is faulty. Maybe something is not working with the detection engine. Maybe the
Yeah,
logs are
occasionally
not
what happens,
flowing.
what I see that happening and causes this most of the time is changes in the logs themselves. Like some vendors just like
Right.
one day out of the blue change the log, and I don't know, take out one of the fields or add another, and suddenly your detection is useless. And it's really hard to detect because you mostly when you measure KPIs, you measure the noisy stuff, and you don't look at the alerts that should be moderately noisy but haven't done anything. Right? So that's also a good point.
Yeah, you also don't always have a benchmark. Like you
Right.
created a rule, maybe it fired in the past, maybe it not, but you only know your environment or a few environments, and you're not sure if it should fire alerts once in a while or not. And you want to have some kind of a metric that tells you that a rule did not fire for a really long time and have some way to uh, check whether it's technically valid. Once you did that, it might be totally valid, and this rule detects a very rare activity, and it's great that it's in place, and it will only fire for real true positive, malicious true positives, uh, and that's okay that you monitor for that, and then maybe you can exclude that or lengthen the period of which you check this rule again. And another distinction that I really like to talk about, maybe a little too much, Yagel, you tell me, is the difference between false positives and benign true positives. So usually we just say false positives for stuff that we don't want our rule to produce. But actually, false positives and benign true positive are two different things. So for example, let's take an example, a rule that detects Mimikatz execution based on process name. So a false positive would be if I will fire and create an alert once Yagel is creating a file called my Mimikatz assignment .docx. And if I will fire for that, it will be a false positive because it's not what the detector should detect. But let's say Yagel is a penetration tester in the organization and he has no malicious intent and he runs it for his own research or work. So that would be a benign true positive because it really happened. The detector detected what it should, but it's not malicious. So I will say carefully that usually dealing with false positives is easier because there's something that doesn't work as expected. In this example, we will look at the rule and say, okay, maybe looking at the process name is not enough and it's too naive, and we need to, for example, add the right extension to the name, maybe look at its parent or child processes, doesn't really matter, but we can reduce the amount of false positives. Benign true positives are usually our real problem because these events happen naturally in environments, and we need to find a way to distinguish between benign and malicious, even though for the detector it looks the same.
Yeah, and a good lesson to take from here is also to manage your exclusions wisely. Because let's take for your example of the Mimikatz. Let's say there is a certain system administrator and he's, I don't know, doing a course and he decided to run Mimikatz on his own computer. Sometimes your instinct is to go, oh, he's an administrator, he's like that's part of his job. I'm just going to exclude him. And not always that's going to be good because this is not a false positive. This is actually someone running Mimikatz, right? And if it doesn't happen, like if it's not an automatic tool that does that 1,000 of times in a week or something like that, then it might not be worth excluding because if attackers love those kind of system administrators that do all that very vague, weird stuff. And
Yeah,
so the next time that an attacker is going to take hold of his computer or his account or anything, then you're going to miss it, right?
definitely, definitely. Our next 2 points are for SOCU KPIs and threat hunting KPIs. If that's okay, again, I'll take it.
Yes.
So again, we can have two types of ways to operate. There's like the routine operational SOC queue, which we call SOC queue, We have somewhere where alerts are being generated. We're going through that one by one. Hopefully, this is already prioritized. And to measure rules that aiming to get alerts into the SOC queue is a little different than, let's say, threat hunting, where we have a certain emerging threat, for example, and we are looking for that. So we will have two types of rules. We will have rules that should 24/7 monitor like the classic stuff, important bottlenecks, and they should be at a very high quality and very low number of alerts because eventually a human is going to go through them and we want to add the relevant context, etc., etc. In threat hunting KPIs, it should be a little bit different because when a researcher comes and to his research, then he is aware that he's going to analyze data and he has much more to deal with and he's looking for something specific. So we can broaden our net and have like a weaker signal type of rules. For example, we can have a, a rule for internal network scanning, and it will fire a lot, as everyone who have deployed such a rule in their environment knows. And perhaps it's okay if we purposed it to be a threat hunting rule, and we will not put it in the SOC queue. Maybe we will have some way to correlate it with other alerts, but by its own, I will need to proactively look for such scanning.
Right. So you need to prioritize only the stuff that you're the most confident in your SOC queue because you only have so much manpower and so much time, right? And some alerts are fine being some sort of building blocks to another thing. Let's say maybe three kind of alerts that each of them individually is not that interesting came up. I won't tell the analyst to go and investigate them one by one, but maybe together they sort of form an interesting story, and now I want to show this to the analyst.
Definitely. You phrased it much better than I did. Let's talk a little bit about prevalence in the wild.
Right, now this is a very hard topic.
Someone put the word hard in capital letters,
Yeah.
uh, and I don't know who that is,
Yeah.
but I agree with him because this is kind of the holy grail of prioritization of rules, right? You want to
Yeah.
tell us a little bit?
Yeah. So one of the metrics that we try to like gain benefit of when we're trying to prioritize a new thesis or a new detection is actually seeing how prevalent that tactic is in the wild. But the reason we put the word hard in capital letters next to it is because, well, not everyone is a threat intelligence company. You don't always have all the access to that kind of data. And using stuff from open source is also a bit tricky because not always the database is going to be updated, not always is going to have all the data you might need. So what I can say about this, few tips, use the like open source kind of repositories. There is one from Microsoft. You can look it up. I forgot its name. Maybe we can get it somehow. But there's one that Microsoft put out from like many customers that they have what kind of alerts they got, what kind of tactics they were. And also you can bolster um, threat reports from various companies. They put like a PDF, I think that's quarterly or something like that, where they put all the interesting insight that they found in regards of threat intelligence. And then you can take all those PDFs, either read through them or another cool thing you can do is actually use artificial intelligence. That's the first time we said this word in this in this webinar.
Yeah.
Yeah,
30 minutes into the presentation, we
30
didn't
minutes
say AI
into.
once.
But here it's really good. It's really helpful. You can use artificial intelligence to there's a really nice one that I like to use called
Yeah, we have a slide for that. So
okay.
let me yeah.
Nice. Yeah, so here you can take, let's say, 10 PDFs from various companies, put them in, ask him a question, and then he can tell you what kind of key points or key tactics have been prevalent in the wild in the last quarter. And actually, I tried that and I correlated it to the Microsoft data set, and I saw that a lot of the points were kind of intertwined. Like the things I saw in the Microsoft data set were the things I saw in the threat report, so it's kind of accurate, at least for now.
Yeah, the tool you're seeing is Google's Notebook LM tool, and Yagel and I really like it. The benefit of it is that it lies less because you have to provide him with the sources. So you can see here, for example, that we provided him with 5 reports of different cybersecurity vendors. You can see CrowdStrike, Elastic, Checkpoint, Microsoft, Palo Alto Networks. And then we can ask him anything we want about that. He has some other very nice features of visualizing the data that we gave him. But for example, I asked him list the top 3 prevalent attack techniques. And even though he didn't like give me a 100% answer, he really shortens the amount of research that I need to do. Of course, I need to validate him, and all the disclaimers for large language models, don't take my word for it. But you can see here in bold that he talks about adversary in the middle, phishing attacks, which are prevalent in identity-based attack and credential compromise, which we know based on our normal research that is a very popular trend. And we can have the reference for it in the reports, and it's a really nice tool to reduce the amount of research that you need to do. And we used it, and
Yeah,
we
when you
have
have the
no
data of how prevalent it is in the wild, then it can help you in decisions for, let's say, if you think a rule is too noisy and you want to try and determine if you want to keep it or you want to let it go. Maybe it's really prevalent in the wild and then you can actually put a little bit more work to it and keep it alive. Or if it's really not that prevalent, then you can throw it away, and it also can help you in determining what kind of new rules you can detect.
definitely, definitely.
Yeah,
Let's
and
talk a little.
yeah,
Go
another
ahead.
point that I really like to talk about is engagement and user activity. You, as your organization's detection engineers, have the really big privilege of having access to the case management system of the analyst, which I think is not really utilized enough by most detection engineers. Like you have a place where the analyst can say or like log everything he did and why he did that. And what I used to do is kind of skim through all that or like export those kind of logs and then find keywords inside that. Let's say
Mm.
you find that in a certain kind of detection, the word false positive appears a lot, and that could be really a really easy and quick win to understand where the false positives are. Or like if you can see that kind of his investigation flow is really long and very, very complicated, then maybe you can find a way to make it a little bit easier for him. So there's a lot of gems in there that people not really utilize. And another thing is engagement. Like how often do the analysts go and investigate that kind of detection? How often they just wave it aside, right? That's another important thing.
Yeah, and you can see the example on the slide is for an alert that we really liked in Hunters for a long time. Detectors with significant engagement and large number of leads in SOQ over 7 days. What a neat name to say that we are looking for noisy detectors in the SOQ that were clicked a lot. This is the essence of it. And over time, we took the most noisy and engaged detector and worked on them and revisited them. They had each had their own issues if they had, and we improved and improved until actually this alert became less efficient for us because we would pick a detector and there would not be much to do for it. So we created a new alert, visited our monitoring system, which we're going to discuss in the next slide, I think, or one of the following slides. But I just wanted to show you a pretty simple example for how we can prioritize and work on what our users experience the most and is also impacting our SOQ the most. Cool. Shall we move forward again?
Yeah, but the little point I want before is the third-party alerts versus the self-developed rules, because sometimes not all of the rules that appear in your SOC queue are developed by yourself, and the third-party ones tend to be the most noisy, and you have the least things to do with it. So
Yeah.
don't be afraid to exclude a lot of things from the third party that you don't need. I often found that sometimes maybe you can differentiate on the confidence. So like some third party vendors have their kind of scoring for it. So maybe you can set a threshold and say anything below medium or like high confidence or score, I don't want to see, and that's fine because usually the low kind of scoring things are just informational or things they use behind the scenes to get more context into big things. So don't be afraid to cut on those and dive into the data and understand what's going on there.
Good point. Good point. So the Delk slide,
The infamous
uh,
dog.
trying to make that stick, but the detection engineering lifecycle. So we started to talk about it in the last slide, so this is a smooth transition. But a key for detection engineering, similarly to development and other areas, is continuous monitoring and improvement. We want to revisit our content periodically based on some sort of alerting system or monitoring system. We gave an example in the last slide, and yeah, so if you remember, we talked about acute and chronic noise in the one of the previous slides, and so this alert looks for chronic noise. And after it stopped being effective for us, we created a rule that looks for detectors which were very noisy in a specific day. And then we changed our monitoring system, deployed it again, waited for alerts, and then fixed whatever came into that, and so on and so forth. So Yagel told me when we prepared for this a nice point that we actually have a KPIs for our KPIs. So yeah,
Yeah.
we
So
do.
it never ends. And the big takeaway from here is that this work is kind of it's a cycle, and you should find your process of going back to it and taking alerts that you already have and looking at them or prioritizing what kind of detections I want to look at the KPIs. And it's really kind of never ending, and you have KPIs on top of your KPIs, but that's good and that's part of the process. And that means you're doing a good thing.
Yeah, yeah. And this is of course only complementary. We always want to have some outside testing, penetration tests, red team. I'm skimming through to make sure we get to all our slides and points, but also your users and customer feedback are super valuable in my opinion. First of all, because a lot of us detection engineers are measured by the satisfaction of those users, not only by the fact that we're protecting them or trying. So their feedback has a lot of weight. And as Yagel explained with his method of going through the comments of alerts, we should find a way to find these product analytics and utilize this feedback to integrate within our detection engineering lifecycle.
Right. Yes, I think we should move on. Yeah. And the
Cool.
last point we have is cost and performance, which is just as important sometimes. In terms of cost, maybe not always it's going to be relevant to you, maybe not always you care about that, but performance should be very much relevant to everyone. And sometimes maybe it happens just that a certain detection is too heavy on computer processing and it takes a lot of time to process or like get all the data it needs. Maybe there's a big time window it needs to look on and that causes it to drag or wait for more events or stuff like that. And that can lead to you missing important leads. And you need to monitor that and try and understand when those things happen and prevent them from happening. Um, yeah,
Yeah, so obviously there's all the aspect of the technology performance, which is a little less what we do, but sometimes we can easily improve our queries or how are we creating rules. So for example, sometimes we define lookback periods which are much larger than what we actually need when we investigate the alert. We define some sort of 90 days to make sure we have all the data, right? That first of all, bring me the data, then I will look. And then we actually are interested in the last 7 days or last day or last few hours. So good optimization can be, let's reverse that. Let's bring only 7 days and have some sort of way to fetch more data if we want to look further back.
Right.
And I don't know how many detection engineers are facing FinOps personnel breathing down their neck, but when it happens, you start to understand that this
Immediately.
optimization can be
Yeah.
very beneficial for you. Uh, cool. And bad performance, as you said, leads to a delay in alert generation, and that may cause either missing an alert or catching it late, which is never good.
Right.
Cool. Takeaways.
Yeah.
So before we go into takeaways, I want to thank everyone that stayed with us to this point.
Yeah.
I hope you had great fun. We're not done yet, but want to make sure to say that. And you hopefully will have this slide anyway. We've put two useful open source tools that we used. It's not sponsored. We don't get paid for
Open
it.
source. Yeah.
Yeah, legal, don't kill me. And yeah, wanna start again?
Yes, so we kind of spoke about beginning that the creation of the rule is just as important as the life cycle in the later stages. Is the rule too reliant on manual exclusions? Is it how to maintain? Maybe I need to let it go. Do I have the correct technology to support my thesis? Right, because every detection starts from like an idea I have of something that I think that is worth detecting. And do I have all the relevant data in my platform? And then we spoke about prioritization and how we can prioritize and how we can even prioritize which kind of detectors do I want to go back to and understand if they're good. Um, we spoke about Delk, use that. Uh, and as Kelman said, um, there are two tools that we personally like and use to simulate threat activity. Atomic Red Team is more for endpoints, and Stratus is more for AWS, and it has a little bit of more cloud things, but AWS is the strong point. We spoke about the importance of context, and not only that the context exists, but that it should be easily accessible. um, Setting your KPIs according to your manpower, priorities, right? You have so many people in the SOC, you have so many alerts. Try to find the sweet spot between the like I'm detecting all I want, and I also have enough time to investigate all of that. Um, we spoke about using the analyst kind of investigation log or like the case management system to your advantage. Try to find keywords and what the users think without actually going out and speaking with them, um, noise, and the most important point, in my opinion, is that detection is really not one and done. I don't just create a rule and set it free. Um, I need to come back to it. It's a life cycle. Uh,
Definitely,
Anything else you
definitely.
want to add?
You got it just right.
Any questions?
And
Because
now,
there haven't been any.
yeah, questions.
See
I
that
see
raise their
hands
hand, but there's a
raising.
Q&A box that you need to put your questions in there. Ah, we got one thanks. That's not a question, but I appreciate that.
Okay, so if you have any
Wait,
questions
maybe
and you
someone
were
does have a question. Someone says, add this box. Use it to ask questions.
it's okay, it's okay. Um, if you are shy and you have questions and you want to send it to us, feel free. to reach out later. And we'll be more than happy to discuss detection engineering with you. Yagel and I are very enthusiastic about it. I hope you had fun today and that we were interesting and helpful. And have a nice day.
Yeah, have a great day, everyone.